Hello everyone. Today we are going to see editorial of Leetcode question number 240 where we have to search in a matrix. But if you will see, this matrix is not a small matrix. It is given that every row is sorted in ascending order from left to right and every column is sorted in ascending order from top to bottom. And we will be given a target where we have to say that if target is present we have to return true, and if target is not present we have to return false. So let's see the editorial for this question. So question is very simple. We have to given a key and there is a matrix given. In this matrix we have to search. So if we have to write its brute force approach will be very simple for this. In this what we will do is we will go to each and every cell and we will check that it is equal to key or not. So if I have to write the brute force code, so let's suppose n is the length of row and m is the equal to number of columns. So can I write that for I is equal to 0 to n minus 1 and for j is equal to 0 to m minus 1, means that we will search for each and every cell where if my matrix of I j, if it is double equals to key, so can I say that I will return true? Now once we are done with searching in each and every cell and we didn't able to find any answer, so in that case we can say that we will return false. So as we are searching in each and every cell, so there are total n cross m cells, so time complexity in this case will be n cross m. And in Leetcode it is given that n comma m is less than equal to 300. So even if you will write brute force solution, it will get accepted. Now suppose if we have to increase the constraint, and I am increasing the constraint as, suppose n is also n comma m is given as less than equal to 10 power 5, then in that case it will be 10 power 5 into 10 power 5, which will be 10 power 10, which will leads to TLE. So how we can optimize this? Optimization is very simple because there are two more inputs given in the question, which says that rows are sorted in ascending order from left to right and column is also sorted in ascending order from top to bottom. So if we will utilize this, then we can easily able to solve this problem and we can reduce its time complexity. So what is the meaning of row is sorted from left to right and column is sorted from top to bottom? If you will see that each rows are sorted and each columns are also sorted. So if you want to find the maximum element in this matrix, you will get the maximum element at this position. So this will be the maximum element. Now let's see that how we can optimize this time complexity and solve this in a better approach. Suppose it is given to us, let's take key is equal to 5. What we will do is we will start searching from here. Now when we will start searching from here, we will see that we have 15. When we have 15, we will see that this 15 is greater than key. So if it is greater than key, suppose if we will come down, so can I say that this row will have the values more greater than 5? Means here we have 19. So what we have to do in this case, if key is greater, so can I say that I will go left side. sorry, if key is smaller, I will go on the left side. Again I will get 11. If again I will get 11, I will go on the left side. I will get 7. Again I will go on the left side. I will get 4. Now when we are getting this 4, now my key is greater. So do you think that if my key is greater, then we have to come down? Because columns are also sorted, so we will come down here and we will check that it is equal to 5. When it is equal to 5, we will return true in this case. Let's take one more example and try to understand this in more clear way. This time, let's take our key is equal to 23. So if our key is 23, we will start searching from here. So now we will check that first we have 15. So we are starting from here and we see that our key is greater than the current cell value. So if I will write here, my key is greater than matrix of I, j. If it is greater, so can I say that we have to come down? How we will come down? As we are seeing that this is ith row, suppose, then we are coming to I plus 1 row. So in this case, can I do I plus plus? Now we will come here 19. Again we will see that our key is greater. So again if our key is greater, I will come down, I will get 22. Again my key is greater, I will come down, I will get 24. Now you will see that now my key value is smaller. So can I say that if my key value is smaller than matrix of ij, so that we have to move to left side? Now suppose this is jth column, so can I say that this cell is j minus 1 column? So here we are doing j minus minus. Now we will go to the left side. I will get 17. When you will get 17, you will again check that your key is greater. So if your key is greater, I will again do I plus plus. So I will come down, I will search for 26. I will get 26. Again you will see that your key value is smaller. So if it is smaller, we will move left on the column and I will move here, I will get 23. So whenever we find this 23, so can I say that I will return true? Just we are going with this institution that whenever my key value is greater, I am coming down, and whenever my key value is smaller, I am going on my left side. Now let's take one example where we will not able to find that. In that case our answer will be false. Let's take key is equal to 19. In this case what will happen? We will start from, okay, 19 is already present, so we will take, let's take 20. So we will start from 15. We will see that our key is greater, we will come down. So I will get here 19. Again my key is greater, I will come down, I will get 22. Again we will see that now my key value is smaller. So if my key value is smaller, I will go to left side, I will get 16. Again my key value is greater. So if it is greater, I will come down, I will get 17. Again my key value is greater, I will come down, I will get here 26. Now my key value is smaller. So we will keep on moving on the left side. So I will get here 23. Again key value is smaller. I will get 21. I will move here. I will get 18. When you will get 18 here, you will see that your key value is greater. So you will come out, and this part is you are crossing the boundary of the matrix. So you will say that you will return false, as you didn't able to find the answer. So talking about this time complexity, so can I say that we are following two paths? One is coming down and we are going on the left side. Either we are coming down or we are going on the left side. So can I say that once we are iterating on the entire row and once we are iterating on the entire column and we are finding the solution. So time complexity in this case will be r plus c, which is nothing but n plus m as given in the question. So I hope this question means it is clear for you that how we are optimizing this. Now if we have to write its code, how we will write its pseudocode. Let's see the pseudocode for this. Suppose again n is our number of row and m is number of column. So if it is the case, we have to start from this cell, right? So for this cell, my I value will be 0 and j value will be, if you will see here, this is nothing but m minus 1. So it will be m minus 1. So now coming to this, whenever we are crossing the boundary, so crossing the boundary means either we are crossing this side or we are crossing this side, we have to break this, or we may cross this side also by going up. So what we can write here is, we can write here while my j value is greater than equal to 0, means that we are not crossing this side, and my I value is less than equal to n minus 1, means that we are not crossing this side also. So in this case, so can I say that we will keep on moving? So we already know that how to move in this. So what will be the, means when we find the answer, so can I write here matrix of ij, if it is double equals to key, so in that case I will directly return true. Now let's talk about other cases. We already know what are the other cases. Here we have already mentioned that how we are following. So here we have already seen that. So can I write here else if my key is greater than matrix of I j. In this case we are doing row plus plus. Else if my key is smaller than matrix of ij, sorry, we are doing here I plus plus, so I is representing our row. So if my key value is smaller than matrix of ij, so in this case can I say that we are doing j minus minus. Now we will keep on moving here, and we know that if we have to find the answer, we will find here only. In this, if we will not able to find the answer, so at last we will return false. So this is the pseudocode and approach where our time complexity is n plus m. Previously we have seen an approach where our time complexity was n cross m. We have optimized this to n plus m.